Okay, so today we're going to be talking about systems of equations and how to solve them using elimination. So first things first, in order to solve anything with elimination, your your two equations that have to match up, meaning the x has to be over the x, the y has to be over the y, the constant has to be over the constant. Okay, that's the very first thing. Next thing is you're going to look to see if there is a number that is the same on both variables in both equations. Okay, so like in this example, the y's have the same number, 6, right? Now, depending on if they have the same sign in front or different signs, you're going to combine them with addition or subtraction. Your goal is to get them to cancel out. You want to get them to go to 0 so that you can solve for your remaining variable. So if they are different signs, so that means like one's positive, one's negative, you add your two equations together. Okay? You can't even see what I'm writing. Okay, there we go. So if they're different signs, you would add them together. If they are the same, meaning you have two negatives or two positives, you would subtract. Okay? So for example, looking at this problem, these are the two numbers, or the two numbers are the same, so they have different signs, which means I'm going to add. So I'm going to add these two equations together. So I'm going to combine these two equations, and it's just like basically what you did in elementary school where you combined or added straight up and down, right? So 7x plus negative 2x is going to be 5x. Negative 6 plus 6 is 0, so it's gone. The y's are gone, they're out of the way. And then negative 30 plus 30 is also 0. Okay, that leaves me with 5x equals 0. We would divide by 5. And x is going to equal 0. That gives me half my answer. Again, with systems, you're looking for where your two lines intersect. Okay? This is the x coordinate. To get the y coordinate, I would just plug it into one of these equations. Doesn't matter which one. Let's do this top equation. So I'm going to replace that x with 0. So 7 times 0 minus 6y equals negative 30. 7 times 0 is 0. So I'm left with negative 6y equals negative 30. Okay, then I would divide by negative 6, and y is going to equal positive 5. So my final solution, the ordered pair to the point where these two lines intersect, would be 0, 5. And that would be my answer. Okay, now, next thing we're going to talk about, let's look at number 7. So this one, there is no number that these two variables have in common. Negative 14, 7, negative 12, 6, they don't have the same number. So if I wanted to combine them to cancel them out, these are not going to cancel out one of my variables because I have to have the same number in each one in order to cancel out. So this is where I have to do something to one of my equations. And what I do is I usually multiply. So I'm going to look at, if I wanted to get 7 to be 14, what would I have to multiply by? Well, I'd have to multiply by 2, right? If I multiply 7 by 2, I have to multiply everything in that equation by 2. So I would get 14x plus 12y equals 6. And let me rewrite the top equation now. It was negative 14x minus 12y equals negative 6. So these have different signs, so again, I'm going to add them together. So add 14 plus negative 14, 0. 12 plus negative 12, 0. 6 plus negative 6, 0. Or sorry, I wrote 6 there. That's 0 as well. Okay? So I'm left with 0 equals 0. Now, whenever both my variables cancel out, it's going to tell me it's one of two possible answers. If both my variables are gone, I look at what's left. If I have a true statement, that means no matter what I plug into these variables, it's always going to cancel out, and I'm going to be left with something true. That means everything would work. So that means that no matter what, this would be a true solution. So this is what we call infinite solutions. Okay, if I had been left with 0 equals 5, that is not true. Again, no matter what I plug in, the variables would cancel out. I'd be left with something not true. That would have been a no solution. But this is an infinite solution. Okay? Let's look at another example. Let's look at, really, everything can be multiplied by 1. Okay, so let's look at one where we have to subtract. So looking up here at this problem, we have the same number here by the x's. They're both -2. They also have the same sign. So that means I'm going to subtract to get them to cancel out. Now this is one that you really should be double checking everything on your calculator when you are subtracting, because this is where the most mistakes are made. When you do -2x and you minus a -2x, you have the same sign right there, right? Those basically cancel out and turn it into a positive. So -2 minus -2x would be the same thing as -2x plus 2x, which is 0. So that's gone. -5 minus a -9y is like -5 plus 9y, which would be 4y. -7 minus -11 would be like plus 11, which would be 4. Okay, and then we divide by 4, and you get y is equal to 1. And then to get my other answer, I would plug the y back in to one of the equations. If I plug it in the top, I would get -2x minus 5 times 1 equals -7. -5 times 1 is -5, so I'd add 5 to each side, which gives me -2x is equal to -2 divided by -2, and x is going to equal +1. So your final answer is going to be 1, 1. Okay? Then, the last one I want to talk about is this one right here. Again, in order to use elimination, all the same types need to be over each other. They need to match up in each equation. So this top equation has a constant and an x on the same side, and then it's equal to a y. The bottom one has them all on the same side. So in order for me to actually use elimination, I need to get them to match up in each equation. Easiest way to do that would probably just be to add the 3y to each side, which would give me, let me rewrite the top equation. It would be -22 plus 9x equals -8y. Okay, and then the new equation down here, if I reorganize this top front, it would be -21 minus 18x equals +3y. Now they match up, so I can combine them to cancel them out, but we still don't have the same number on either of these variables. So I'm going to have to multiply this top. To get it to 18, I'd have to multiply it by 2. I have to multiply everything there. So I'm going to get -44 plus 18x is equal to -16y. Now I can combine them. They have different signs, so I'm going to add. So -21 plus -44 is going to be -65. X's cancel out. -18 plus 18 is 0. And that's going to equal 3 plus -16 is -13y. And then last step here, I would have to divide by -13, which is going to give me +5 for y. And then I take that and I plug it back into any of these equations. Okay? There's lots of equations I can choose from. Let's plug it back into this original top equation right here. So I'm going to replace the y with 5. So -22 plus 9x equals -8 times 5, which would give me -40. And now it's a party problem. I got an acquaintance, best friend. I'm going to get rid of the acquaintance first, add them out the door. Gives me 9x is equal to -18. Divide by the best friend, x is going to equal -2. Okay? So my final answer is going to be -2 and 5. And that is how you solve for systems using elimination.